Hi, my name is Oktay. Today's video is about the chemical element silicon. It is a very important chemical element. It has the atomic number 14. It is in the carbon group. Density is about 2.3 grams per cubic centimeter, and the molar mass 28 grams per mole. And silicon 28 isotope is another example of a very common isotope with an even number of protons and neutrons. The electronegativity of silicon is lower than hydrogen at 1.9. Silicon is the 8th most common element in the universe. This picture shows you the abundance of silicon in the Earth's crust. You can see it is here. It is number 2 in abundance, and it is in Earth's crust as silicate. This picture shows you the nucleosynthesis of all the chemical elements. Silicon is here, and you need very extreme temperatures and pressures to make silicon, and these conditions are in massive stars and explode in white dwarfs. And this nuclear reaction is called oxygen burning. Two oxygen nuclei merge together. You get silicon-28 and byproduct helium-4. This picture shows you the cycle of silicate. You can see again the importance of water for transport of this of the silicate, and the ground can bury silicate, and it can also set silicate free. Silica is known for its for giving its stability to plants. The silicon production per year is over 8 million tons, and you make it by reduction with carbon at 2000 degrees Celsius. This gives you silicon and byproduct carbon monoxide. Applications of silicon are in electronics, solar cells, and alloys. There's a group of compounds called silicones. They are used for insulation and greases, and silicates can be used for Portland cement and ceramics. Silicones are polymerized siloxanes. They are made by the hydrolysis of dimethyl dichlorosilane. The byproduct is hydrogen chloride. And these compounds are known for their chemical and thermal stability and their low toxicity. That's why they can use them in rubber and insulation. This is how you make a very pure silicon. This method is called zone melting. You have your silicon piece, you move it slowly to the bottom. Once it reaches the warm zone, it is melted. And as soon as it leaves the warm zone, the crystallization starts, and the impurities stay in the warm zone, in the molten zone. And the trick is you can do this several times with the same silicon piece, and this gives you a very pure silicon. And at the end of the process, you just have to cut the top part with the impurities, and that's how you make a very high purity silicon. This one, a very important property of silicon, it's a semiconductor. This picture shows the energy bands. And this is a result of the Pauli exclusion principle. That's quantum dynamics. It says no two electrons can have exact same state. That gives you these band structures of conduction band in white and the valence band in black. In metals, these bands overlap nicely. That's why they are conductive. In insulators, they are widely separated. And semiconductors are in between. They have a gap, but it's a very small gap. And you can tune it by making p-type and n-type semiconductors. This is how you do it. This is called doping. It changes the conductivity of silicon. You can do n-doping with phosphorus and p-doping with aluminum. This is the basics of electronics. This picture shows you the Moore's law. That's the number of transistors on microchips doubling every 2 years. The y-axis is logarithmic, and you can see the increase, exponential increase, and this is still going on. This picture shows you the development of the solar cells, of all the generations of solar cells. The silicon solar cells are at about 20% to 25% efficiency. There's another candidate, perovskites, a very interesting candidate. They're at about 10 to 12% efficiency. This is still in research. You can make tandem solar cells with silicon and perovskites that gives you about 30% efficiency. And the record is with multi-junction cells, they have 47% efficiency. This picture shows you the price decline in solar modules. Both this y-axis and the x-axis are both logarithmic. And yeah, there's a strong decline, exponential decline. This is a picture from the city of Freiburg in Germany. In my last video, I've shown you there's also a decline in lithium-ion battery prices, and together with the decline in the solar cell prices, now is a very good time to think about buying solar cells and battery systems. This picture shows you the solar radiation in different countries, and you can see South Europe, Africa, Middle East, big parts of America, Australia, of course. They're all China, all very good places for solar cells or solar energy. However, every technology has its limits, and silicon is a dark material, and if it's exposed to sunlight, it gets hot, and these atoms start moving a bit more, and this blocks a bit the flow of the electrons, and that's why the efficiency goes a bit down at very high temperatures. That's why this alternative is very interesting. This is the solar thermal energy generation at big scale. There are two models. On the left, you have the model with the tower in the center, and on the right, the one with curved mirrors, which concentrate the sunlight into the tube that's in the middle. And both these concepts have mirrors that are computer controlled. They follow the sun in the sky. And the advantage is that these systems have built-in energy storage. You can store the heat, and after sunset continue to produce electricity. That's an advantage over solar cells. And these systems are very low maintenance. You don't need fuel because it's provided for free from the sun. All you have to do is keep the mirrors clean. Yeah, that's all. This is how the solar pipe works. The curved mirrors concentrate the sunlight into the pipes. You get this typically oil that's heated up, and from there on it's like a normal conventional power plant. You turn the heat into electricity. This is how you can store heat with a compound that's called zeolite. These are aluminosilicates. And you can use the desorption and adsorption of water for energy storage. The left picture shows you the structure of this compound, and the right picture shows you the three-dimensional structure that can nicely take the water molecules. This is a practical example from California, USA. This is Ivanpah Solar Power Facility. It cost $2.2 billion, but it has a capacity of 392 megawatt. That's a lot. You have one-time installation cost, and then you can run this power plants for decades. That's why, in my opinion, they make economically a lot of sense. You can also build solar panel arrays. These work even in Germany with not the highest solar radiation. Yeah, that's another very efficient method to produce electricity in a clean way and very silent and very effective. This is solar water heating. You can use thermal collectors to heat up water for shower, for example. This is a picture from China, but again, this works also in Germany or Turkey. This is very popular. And this is another very elegant method to produce energy without burning fossil fuels. This was today's video about chemical element silicon. My next video will be about this compound graphene. It's very interesting. Thank you for watching. Have a nice day. Bye-bye.